Good evening, class. As for question number 8, it states that to use the empirical rule or Chebyshev theorem to provide a prediction of the spread of the data that is within 3 standard deviations away from the mean, which consists of x bar plus and minus the 3 sigma. For our data set, we decided to use the empirical rule. We have the 117.73 and the 20.899 from up top. We got it from the 117.73 as our mean, and the 20.899 is going to be our sample standard deviation. As we make our way back down, now we're going to take the 117.73, add that by the 3, which is going to multiply by the 20.899. And this number here, the 180.427, is going to be our upper. As for our lower, is going to consist of the 117.73 minus the 3, timesing by the 20.899, which is going to give our lower, which consists of the 55.033. As for our conclusion, approximately 99.7% of the data lies within 3 standard deviations of the mean, 55.033 and 180.427 ounces. As for question number 9, it states that to create a confidence interval for the population mean, use a 90% level of confidence, provide the critical value, a sketch of the critical value, the standard error, and all formulas and calculations. As for our critical value, we have a 1.645 because that is the value for the 90%. As for the formula, the standard error is going to consist of 1.645 times it by the standard deviation, which is going to be the 20.899, divide that by the square root of 200, which is our n value. And that's going to give us a 2.431. As for our confidence interval, it's going to be x bar minus e less than mu less than x bar plus e. And that's going to give us a 117.73 minus 2.431, which is going to be less than mu less than 117.73 plus 2.431. And this is going to give us a confidence interval is approximately 115.29, 120.17 ounces, with a critical value of approximately 1.645 and a standard error approximately of 2.431. And right here is going to be our code, which is going to consist of the t interval, and this is the code that we use, which is going to be 0.05, and the df is 199 because you take the 200 value and you're going to subtract it by the 1, and it's going to give us the df right here, which is going to give us the 1.645. As for question number 10, it asks us to create a confidence interval for the population standard deviation. Use a 95% level of confidence, provide the critical value, a sketch of the critical value, the standard error, and all formulas and calculations. Once again, the critical value is going to consist of 1.96. As for the standard error, it's going to be E equals the standard deviation, divide that by the n value, the square root of n is going to give us a total of 1.48. As for the formula, we have the square root of n minus 1 times it by the standard deviation of 2, the power of 2, second power. Divide that by the x second power r is less than the standard deviation less than by the square root of n value minus 1 times it by the s standard deviation 2, divide that by the x to the second power l. So that's going to give us this formula right here that we see in the bottom. It's going to be 200. It's going to be the square root of 200 minus 1 times that by the 20.899 to the second power, divide that by the 239.96. As we make our way across, it's going to be less than to the square root of 200 minus 1 times that by the 20.899 to the second power, divide that by the 161.83. For our answer, it's going to consist of 19.03 and 23.18 ounces. As for our conclusion, we are 95% confident that the population standard deviation interval is approximately 19.03 and 23.18 ounces, with a critical value of approximately 1.96. And this is the diagram that we have from StatCrunch after punching in for our numbers. Let's move on. As for question number 11, it asks us to design a hypothesis test for the mean, proportion, variance, or standard deviation. For the mean, we have from the 117.73. The standard deviation for here is going to be the square root of the sum times the x minus x bar times it by or my apologies, to the second power, divide that by the n minus 1. And then that's going to give us our answer, which is going to consist of the 20.899 that we have from up top. For the test statistics, it's going to be t equals x bar minus m, divide that by the standard deviation, divide that by the n value, the square root of n. That's going to give us a 117.73 minus 110. Divide that by the 20.89906,588. And you're going to divide that by the square root of 200, which gives us the 5.23. As for our critical value, we're going to have 1.97 that we see right here. As we make our way down, you can see our one summary, T summary hypothesis test. For our HO and HA, we took this from StatCrunch. As we move forward, we have our T distribution with the DF equals 199. T-stat is going to be 5.2308, and the p-value is going to be 0.0001. As for our conclusion, it's going to reject HO because T equals 5.23 is greater than the CV equals 1.97. C equals 0.95 and alpha equals 0.05. And that is all.